There is a wall inside a museum in Philadelphia that has a locomotive sealed behind it. Not parked, not displayed, sealed. The room was built around the machine because the machine was too big to ever come back out, and the wall was finished after it went in. Somewhere north of the Delaware River, a helicopter plant now stands on 600 acres that used to shake 24 hours a day, with the sound of steel being beaten into engines that pulled the entire country behind them. And on that same stretch of riverbank, if you go looking, you will not find the buildings. You will find a shopping center, a power plant, and one tower shaped like a cross, standing alone in a parking lot, the last visible bone of an empire that once built more locomotives than any company in the history of the world, over 70,000 of them, more than any builder before it or since. Machines that hauled coal out of Appalachia, hauled soldiers to 2 world wars, hauled grain and steel and mail and every other thing this country ever needed, moved from one place to another. For 125 years, if a railroad in America, or Russia, or Argentina, or Egypt needed an engine, there was a real chance it came from one address, one company, one furnace. So how does a company like that disappear entirely, bulldozed to the foundation, its own records burned by its own management, its name reduced to a tower in a parking lot, and a locomotive bricked into a wall? Was it the war? Was it the money? Was it simply outrun by something faster? Or is the real answer worse than any of those, that nobody outran them at all, and they walked into the grave with their eyes wide open? Here's the part that should bother you. You won't find the killer among the usual suspects. No rival, no strike, no single catastrophic year. The thing that destroyed the largest locomotive builder on Earth was the same thing that made it the largest locomotive builder on Earth: mastery. They got so good at building fire-breathing machines out of iron and rivets and pressurized steam that they could not, would not, believe anything else could replace it. And that belief cost them everything. This is the story of the empire that mastered steam so completely that steam became the trap. And before we get to how it died, you need to understand what it actually built, because the numbers alone should not be possible. The numbers that should not be possible. It killed men on a schedule. Start there. A company that built peaceful, useful machines, trains that hauled families and mail and Christmas presents, buried its own workers with a regularity that never made the papers, because burying workers was simply what industrial Philadelphia did in those years, and nobody thought to count. More than 70,000 locomotives left this one company's doors between 1832 and 1956. Stack that number next to anything else built by human hands in that period, and it barely makes sense. Detroit didn't build 70,000 of any single car model in its first decade of trying. This company did it in steel monsters that weighed more than 100 tons apiece, built almost entirely by men standing at hand tools, in a plant that ran through the night, every night, for generations. At its peak, this one company employed close to 20,000 people at a single riverside site. 20,000 men reporting to one address every morning to build machines that could kill any one of them in under a second if a chain slipped or a boiler let go. It built the most powerful steam locomotives that have ever existed, anywhere, full stop. Engines so strong they could drag 18,000 tons of iron ore behind them, a load heavier than 50 jumbo jets, using nothing but fire, water, and steel. Engines so far ahead of anything else on the rails that the railroads that owned them refused to retire them, running them years past when every other steam engine in America had already gone to the scrapyard. It became an arms manufacturer, almost overnight. During the First World War, this locomotive company turned out rifles at a rate of 6,000 a day and shells by the millions, on the same riverbank where it built engines. And on one April morning, on that same riverbank, 133 of its own workers, most of them women, were killed in a single explosion before lunchtime. That's still coming. Hold on to it. And here's the fact that should stop you cold. Baldwin's own chairman, stood up in front of an audience, decades into the firm's life, and promised, on the record, that nothing on earth could replace what they were building. He was wrong within a single generation, and he never once tried to change course. Out of nearly 150 competing locomotive builders that operated in North America across the age of steam, this one outlasted almost every single one. It survived economic panics, world wars, bankruptcy, and a founder's death. And then, in the end, it didn't lose to a rival company at all. It lost one order, a single contract, from the one railroad that had bought from them longer than any other customer alive. And that was the moment the whole thing came apart. We'll come back to that order. It's the reason this video exists. And when it was finally truly over, the 600-acre fortress this company built to last forever was torn down piece by piece, building by building, over the course of almost exactly 1 year. The wrecking crews worked straight through, and nobody with the power to stop them ever tried. An empire that built the machines that moved a nation came down slower than it took most of those machines to build, and faster than anyone who worked there ever thought possible. How does that happen to the biggest builder in the world? To answer that, you have to go back to a jeweler's workbench, decades before any of this existed, because the thing that eventually crushed this company was baked into its foundation from the very first day. A jeweler builds a monster America cannot yet tame. The man who built an empire out of fire and steel started his career polishing gold. Matthias Baldwin was a jeweler in Philadelphia in the 1820s, a careful, precise craftsman who spent his days working metal down to fractions of an inch for necklaces and watch cases. Nothing about that career explains what came next, but jewelers understand tolerance, how far a piece of metal can bend before it fails, and that instinct, more than anything else, is what let Baldwin see a way into an industry that barely existed yet. In 1825, Baldwin partnered with a machinist to build tools for bookbinding and calico printing. Ordinary industrial work, nothing that hinted at locomotives. But the shop needed power, and the power available was weak and unreliable. So Baldwin built his own small stationary steam engine to run his own equipment. It worked, and it worked so well that other shops in the city started asking him to build engines for them too. Here is the enemy this story starts with. America in the 1820s had almost no way to move anything heavy across land. Rivers and canals ran where geography allowed and nowhere else. Wagons and horses could not scale to a growing country. England had locomotives already, hauling coal along short lines. But English machines were built for English distances, English curves, English rail. America was bigger, rougher, and cheaper, and nobody had proven that a steam locomotive could survive it. In 1831, Baldwin got the chance to try. The Philadelphia, Germantown, and Norristown Railroad needed an engine, and they came to the jeweler who had already built one small demonstration locomotive for a local museum exhibit. He said yes. There were almost no machinists in the city capable of the precision this job demanded. Baldwin had to teach grown men on the spot how to do work that had never existed in America before. Cylinders were bored out using a chisel wedged into a block of wood, turned entirely by hand because the machine tools that would later make this trivial did not exist yet. Baldwin did much of the most difficult work himself, night after night, because there was no one else in the building who could. On November 23, 1832, the finished machine, a squat, black, coal-burning engine nicknamed Old Ironsides, was rolled onto the rails of the Philadelphia, Germantown, and Norristown line for its first real test. It moved at a walking pace, barely faster than a man could jog alongside it. The small crowd that had gathered to watch a piece of American industrial history did not see a triumph that first hour. They saw an oversized kettle on wheels, coughing along the track, looking every bit like it might quit before it reached the end of the line. But could it actually hold together under real load, real distance, real weather? It could. Within weeks, refinements to the boiler and the gearing pushed Old Ironsides up to 28 miles an hour. a speed that, in 1832, felt closer to flight than to travel. Nobody standing trackside that year could have told you how thin the margin was. Early locomotive boilers across the industry were prone to catastrophic failure, welded and riveted by guesswork, tested by nothing more than hope and a slow build of pressure, and a burst boiler could kill the crew standing on the footplate before they even understood what had gone wrong. Baldwin's first machine beat those odds. Plenty of builders across the industry did not. The locomotive worked that line for more than 20 years, and the order that had seemed like a one-time favor for a local railroad turned into a permanent business. Baldwin Locomotive Works was born from a jeweler solving one specific, local, impossible problem, and discovering that every railroad in the country had the exact same problem waiting for him. The debt this pays, that unbelievable scale you heard about in the opening, the 70,000 engines, the 20,000 workers, all of it traces back to this one cramped shop, where a man who had never built a locomotive in his life was teaching other men how to bore a cylinder with a wood chisel. Growth after that was fast, and it was violent in its own way. By 1840, fewer than a decade after old Ironsides first crept down the track, Baldwin's shop on North Broad Street had turned out more than 150 locomotives. 50 years later, that same operation employed 3,000 laborers and was producing nearly 600 engines a year, one locomotive completed, tested, and shipped roughly every business day. The plant on Broad Street was never big enough for what it was becoming. It sat crammed into a few crowded city blocks, hemmed in on every side by a growing Philadelphia, and every expansion meant buying out a neighbor, tearing down a row house, squeezing one more forge into an alley that had no business holding one. The company's own ambitions were, quite literally, running out of room. Growth was never a straight line. Economic panics in 1837 and again in 1857 cut production in half almost overnight, and Baldwin survived both by shrinking fast and rebuilding faster. Then came a war that should have destroyed it outright. At the start of the Civil War, close to 80% of its business went to railroads in states that were about to secede. Losing that market in a single year should have been fatal. Instead, wartime demand from the Union military and the Pennsylvania Railroad filled the gap, and the firm came out of the war bigger than it went in. A pattern of near collapse followed by explosive rebound that would repeat itself for the next century, each time teaching the same lesson: build bigger, build faster, and the market will always come back. That lesson was true for 80 years. It would not stay true forever. By the final decades of the 19th century, this was no longer one company competing quietly for orders. Rivals were consolidating into a single aggressive competitor, built specifically to challenge it, pooling smaller regional builders into one combined operation, with the manpower to fight for the same contracts on the same terms. The company on Broad Street answered the only way it knew how: building more, building bigger, and trusting that raw output would always win. That squeeze is what set the stage for the next chapter of this story. A chapter built entirely around one word: bigger. Bigger furnaces, bigger cranes, bigger risk. The company that had learned to build locomotives by hand in a cramped Philadelphia alley was about to build the largest, most dangerous locomotive factory on the face of the earth. And the man who would push that expansion through, over the objections of his own board, was a young engine inspector who hadn't even been born yet when old Ironsides first rolled onto the tracks. Inside, the fortress where fire becomes a machine. By the time this company was done expanding, it could finish more than 3,000 locomotives a year from a single address, and every one of those machines had to survive a gauntlet of fire, molten metal, and crushing weight before it ever touched a rail. The man who pushed that expansion was Samuel Vauquelin. He joined Baldwin as a young engine inspector, checking the quality of locomotives before they left the shop, and rose through the ranks with a mind built for exactly the kind of problem the firm now faced. In 1889, he patented a new compound engine design that squeezed more power out of the same fuel, an invention so effective that within 2 decades, over 2,000 locomotives had been built to his patent. He was, by any measure, one of the sharpest engineers Baldwin ever produced. And it was Vauquelin, now rising toward the presidency, who argued that the cramped Broad Street plant had to go, that the works needed room to build on a scale nobody in the industry had ever attempted. His board pushed back. Expansion meant debt, and debt was already a problem. One of the firm's partners had just died, owing the business $6 million. But Vauquelin's vision won out, and construction began on a new works 15 miles south, in a town called Eddystone, on land wedged between the railroad and the Delaware River. What rose there was built on the scale of a fortress, 600 acres, more than 100 of them under roof, built specifically so a locomotive could enter as raw iron ore and roll out the far end as a finished, coal-fired machine capable of dragging thousands of tons behind it. Walk that fortress floor by floor, and you walk through a chain of controlled violence. It started in the foundry, where furnaces melted iron and steel down into glowing rivers, poured by hand into molds shaped for driving wheels, cylinder blocks, and frame castings. One splash of that molten metal, one crack in a mold from trapped moisture, and a man standing 3 feet away could be burned to the bone before he had time to react. From there, castings moved to the machine shop, where lathes and borers cut raw metal down to tolerances measured in thousandths of an inch. Precision work, done next to open gears and unguarded belts spinning fast enough to take a hand off at the wrist. Then came the boiler shop, and this is where the real math of danger started to show itself. A single steam locomotive weighed more than 100 tons and needed thousands of rivets and bolts to hold its frame and boiler together. Driven in mostly by hand, glowing red from the forge, tossed man to man and hammered flush before they cooled. Miss a beat in that rhythm, and a man was catching a piece of hot iron with his bare skin. The boiler itself was, in the plainest sense, a bomb. It held pressurized steam that, if a seam failed or a plate weakened, could tear the vessel apart with the force of an explosion. And every boiler that left this plant had to survive a live pressure test before it was ever allowed near a locomotive frame. Vauquelin's own contribution to this chain of danger deserves its own mention, because it wasn't just management he brought to this company, it was engineering. His compound locomotive design, patented in 1889, ran steam through a high-pressure cylinder and then a low-pressure cylinder stacked on top of each other, wringing extra power out of the same shovel of coal. It worked so well that within 2 decades, more than 2,000 locomotives had been built to his patent, and Baldwin's own reviewing engineers at the Franklin Institute called it a genuinely new category of machine, not just an improvement on the old one. But compounding came with a cost nobody advertised. Uneven forces on the crosshead wore parts down faster than a conventional engine, which meant more time in the shop, more hands inside a half-assembled locomotive, more exposure to every danger already built into that building. Beyond the boiler shop sat the wheel and flange shop, the blacksmith and hammer shop, the truck shop, and the tender shop, each one its own small factory, each one feeding parts toward the same finish line. Power hammers dropped forged steel with enough force to shape a connecting rod in a handful of blows, controlled by one man's foot pedal, while 2 others held a glowing bar of metal steady with tongs, close enough to feel the heat radiate off it with every strike. But how do you take a 100-ton half-finished machine and actually put it together? Cranes, overhead cranes ran the length of the erecting shop, the final assembly hall where the whole locomotive came together, hoisting wheel sets and boiler shells that weighed as much as a loaded delivery truck, swinging them slowly over the heads of men working below. There was no margin in that motion. A cable frayed past its limit, a hook seated wrong, and the object drifting overhead stopped being cargo and became a weapon. This was not occasional danger. This was the daily condition of the job. Men working shoulder to shoulder, underneath tons of moving steel, trusting a chain they had not personally inspected, on a schedule that did not slow down for caution. And this fortress did not build one thing. It built everything a railroad could ask for. Squat little switching engines that shuffled cars around a rail yard, and mammoth articulated giants built to drag ore trains across mountain grades. The largest of those giants, a design classed as the Yellowstone type, could put down more than 140,000 pounds of pulling force and haul trains of over 18,000 tons. And they were so good at the job that the railroad that bought them refused to scrap them, running some of those engines well into the diesel era, decades after every other steam design around them had gone to the torch. Not every giant this company built succeeded. In 1916, engineers here designed an engine so ambitious it split its power across 3 separate sets of driving wheels under one boiler, built for a mountain railroad that needed to drag enormous coal trains up brutal grades. On paper, it was a masterpiece of raw tractive force. In practice, it ran out of steam faster than it could climb, choked in a tunnel with barely 4 inches of clearance to spare, and never once completed the job it was built for. The company quietly cut it apart and rebuilt the pieces into 2 ordinary, unremarkable locomotives. Ambition, in this fortress, did not always survive contact with physics. The debt that pays off here, that promise from the opening about a factory capable of outbuilding entire nations, this was how. Not one miracle machine, a production chain, floor after floor, purpose-built so that iron went in one end of a 600-acre complex, and, day after day, a finished engine capable of killing a man in a heartbeat rolled out the other. There is a quieter picture worth holding onto here too. Before the shift horns and the hammer strikes, in the gray hour just after dawn, the yard outside the erecting shop stood almost silent. Stacks of coke and pig iron waiting under a sky that hadn't decided yet whether it would rain. A night watchman finishing his last slow lap past cold furnaces that would be roaring again within the hour. That silence never lasted. It was never meant to. But it was there, every single morning, right before the fire came back on. Because underneath all of that raw industrial power sat a business decision that would eventually matter more than any casting or any crane. Vauquelin, the man who had pushed so hard to build this fortress on the belief that steam demand would only grow, would soon become the very reason the company failed to see what was coming next. His confidence had a name and a date attached to it. We'll get there. For now, understand this. A plant built to run at full capacity around the clock never once, in its entire existence, operated at more than a third of what it was built for. That gap between ambition and reality, a fortress 3 times bigger than the company ever actually needed, is the second quiet danger of this story, one that had nothing to do with molten metal and everything to do with money. That empty capacity would not stay empty forever, and the use it eventually found was far darker than anyone standing in the erecting shop that year could have guessed. The men who fed the furnace. Picture it from the inside for a moment, because the numbers so far have all been about steel. This next part is about flesh. You are standing on the erecting shop floor at 6 in the morning. The air already tastes like coal smoke and hot iron. Somewhere above your head, a crane operator is easing a driving wheel set, cast iron and steel, heavier than a car, toward a locomotive frame that a dozen men are steadying with their bare hands and their full body weight. Nobody is wearing a hard hat, because hard hats do not exist yet. No one has ear protection either. The pneumatic riveting hammers 3 bays over are simply what noise sounds like, all day, every day, until you stop noticing it. And that is its own kind of danger. The day you stop noticing the noise is the day you stop noticing the crane. This was piecework. Men were paid by what they finished, not by the hour, which meant the fastest, most skilled machinists could out-earn almost anyone else in industrial Philadelphia. And it also meant every single man on that floor had a direct, personal financial reason to move fast around machinery that did not forgive speed. The company's own rates barely changed for decades, rewarding raw output above almost everything else. At its peak, This single riverside operation employed close to 20,000 people. Immigrants from a dozen countries stood shoulder to shoulder at the forges, learning trades that barely existed back home, breathing in foundry dust and furnace smoke, shift after shift, year after year, in conditions nobody was tracking or regulating in any meaningful way. Some of them got sick from it. Nobody wrote that down either. The danger here didn't always come from fire or falling steel. Sometimes it came from the calendar. In 1907, this company produced more than 2,600 locomotives and employed close to 18,500 workers. The very next year, after a financial panic tightened credit across the entire country, output collapsed to barely 600 engines, and the workforce was slashed to under 5,000 men almost overnight. For the families depending on that paycheck, the crane overhead was not the only thing that could end a livelihood without warning. A downturn in New York could do the same job just as fast, and with no chance to duck out of the way. And then the war came, and the danger changed shape entirely. When the First World War broke out in Europe, this company did not just keep building locomotives. It started building weapons. A rifle plant went up on company land, employing 15,000 people at its peak, turning out 6,000 rifles a day, nearly 2 million rifles by the time the war ended, a huge share of everything American soldiers carried into France. Alongside the rifles came artillery shells, millions of them, packed by hand with black powder in a subsidiary plant the company had built specifically for the job. Women filled many of those wartime positions, on the rifle line, on the shell-packing line, doing precision work that had, until that year, been considered exclusively men's work. It was, in its own strange way, a kind of opportunity. It was also, as the next chapter of this story will show, one of the most dangerous jobs in the entire American war effort. Somewhere in the middle of all this, the piecework floor, the wartime rifle plant, the 20,000 workers, stood Samuel Vauclain, no longer just an engine inspector, but the man now running the entire company. During the war, he chaired national committees on locomotive and munitions production, coordinating output not just for his own plant, but for the country's entire military supply chain. He was, without question, one of the most powerful industrialists in America. And the very qualities that made him so effective, total confidence in what this company could build, total confidence in fire and steel and steam, were quietly hardening into something that would eventually blind him completely. Here's the thing nobody on that factory floor could have known yet. The exact same conviction that let Vauclain push through the Eddystone expansion, coordinate a war economy, and turn a locomotive company into an armory almost overnight. That same conviction would, years later, cause him to stand in front of an audience and promise that nothing could ever replace what they were building. He would be spectacularly, catastrophically wrong, and by the time that happened, it would already be too late to matter. So what does an industrialist this sharp, this battle-tested, actually miss? Not a fact. A feeling. The one that says a company this big, this proven, could never be caught flat-footed by a machine it hadn't even bothered to take seriously yet. That feeling was already loose in the building, years before anyone said it out loud. You can measure this company in tons of steel shipped and locomotives completed, and dollars of wartime contracts. The people working the floor measured it differently, in burns that never fully healed, in a noise that lived permanently in your ears long after the shift ended, in the particular fear of an overhead crane you learned to live with because you needed the paycheck. Because what came next on that riverbank was not a mechanical failure. It was the worst single morning this company would ever survive, and it happened not in a locomotive shop, but in a building meant to arm a war 3,000 miles away. The morning the empire bled, and the order that finished it. 5 days after the United States had formally entered the war, inside a shell-packing building on the Eddystone riverbank, 380 workers, most of them women, were filling shrapnel shells with black powder, part of an order for 2.5 million shells destined for the front. 18 tons of raw black powder propellant sat, stored inside that same building. At 10 in the morning, without warning, the building tore itself apart. The first explosion demolished the structure outright. Smaller blasts followed within seconds, throwing shrapnel bullets across the surrounding grounds. Fire crews and co-workers ran toward the wreckage before the smoke had even cleared, and one of the responding firemen lost a leg in the effort. By 11 that morning, every hospital in the area was already past capacity, treating the injured in hallways because the wards were full. 133 people died. 55 of them could never be identified. Their remains were buried together in a mass grave at Chester Rural Cemetery, under a single monument, nameless. 12,000 mourners attended the memorial service, including officers of the company itself, standing over a grave that held workers whose names nobody would ever recover. Samuel Vauquelin, Baldwin's president, told reporters in the days after the disaster that the explosion had been planned and executed by maliciously inclined person or persons, a public accusation of sabotage that deflected attention from any question of oversight or safety on the firm's own factory floor. No cause was ever conclusively proven. It may well have been an accident, the almost inevitable result of packing black powder into shells by hand, at speed, under wartime pressure, inside a building holding 18 tons of propellant. Nobody in a position of authority ever said that plainly. Vauquelin himself said sabotage, and the record was allowed to close there. That was the deadliest single morning in Baldwin's history. 133 graves, purchased not by a locomotive failure, but by a war contract taken on to keep wartime revenue flowing. And it happened on the very ground where, within a decade, the firm would pour its entire future into a brand new 600-acre locomotive fortress, betting everything on the belief that this kind of scale, this kind of production power, would keep it on top forever. That belief did not survive contact with the 1930s. So what, exactly, did the man running the largest locomotive works on Earth say out loud, on the record, that he could never take back? In 1930, with a diesel-powered future already creeping onto American rails, Samuel Vauquelin stood in front of an audience and delivered a line that would define the rest of this story. He declared, on the record, that the company's steam technology would ensure the dominance of the steam engine until at least 1980, a specific year, half a century away, spoken with total certainty by the man who had built the largest locomotive works on Earth. He was not alone in that certainty. A few years later, one of the company's own directors of sales stood in front of the industry's trade press and dismissed the entire diesel movement as a passing fad, insisting the country's railroads would no more run on diesel power than they would run entirely on electricity. Two of the most senior men in the building, years apart, saying the same thing in different words. This cannot replace us. For a while, it looked like Baldwin might dodge the whole problem entirely. When the Second World War broke out, this fortress that had spent a decade running at a third of its capacity suddenly had more work than it could handle again. The government handed out war contracts worth more than $500 million across its plants, and the workforce climbed back toward 20,000 almost overnight. Alongside locomotives, the shops that had spent a century pouring wheel castings and boilerplate started pouring tank armor instead, turning out variants of the M3 Lee and the M4 Sherman, along with naval guns for warships that would never touch a rail line. For a few years, it must have felt like proof that Vauquelin had been right all along, that the firm could build anything, adapt to anything, outlast anything. It was a hope beat, with no floor underneath it. The tank contracts ended when the war did. And the war had done something far more dangerous than keep the company alive. It had bought Baldwin 4 more years of not having to solve its diesel problem at all, while its rivals used those same 4 years to refine engines that were already ahead. When peacetime orders resumed, the company was exactly where it had been in 1939, except older and further behind. Meanwhile, across the industry, a rival by the name of Electromotive, backed by General Motors, was doing something this company refused to do. It picked one diesel design, built it the same way every time, refined it steadily instead of custom building a new version for every customer, and offered railroads something Baldwin's steam-era craftsmanship never could: predictable, interchangeable, mass-produced reliability. This company kept building locomotives the way Matthias Baldwin had built old Ironsides a century earlier, one at a time, hand-fitted, unique to each customer. That approach had built an empire. It was about to become a liability nobody in the boardroom was willing to name. By 1948, steam locomotives made up barely 2% of new orders across the American rail industry. A year later, that number reached zero. The company scrambled, merging with a smaller rival to form a new combined operation, rushing diesel designs to market that arrived late and performed worse than the competition, watching its most reliable customers quietly place their orders somewhere else. If diesel had already won the argument by 1949, what was left that could actually finish this company off? And then came the order that ended it. This wasn't a company that lost a contract. It was an empire that lost its century. In 1956, the Pennsylvania Railroad, the single most loyal customer Baldwin had ever had, a relationship stretching back more than 100 years, finally decided it was time to fully retire its steam fleet and buy diesel power at scale. It turned to electromotive instead, and the reason had nothing to do with safety or quality. Baldwin's engines were neither unsafe nor badly built. Electromotive simply delivered standardized, serviceable, interchangeable locomotives on schedule, and the firm, even after everything it had built, could not. The Pennsylvania Railroad's decision landed like a verdict: 70,000 locomotives built, and it took exactly one lost order to crush an empire that size. Because by 1956, Baldwin had nothing left in reserve to absorb the blow. After 125 years of continuous production, after 2 world wars, after outlasting nearly 150 competing builders, the firm closed most of its remaining plant that same year and produced no more locomotives for the American rail market. The last few units it ever built were 3 experimental passenger locomotives, delivered in 1956 to 2 railroads that would themselves soon abandon steam entirely. Nobody threw a party. Nobody wrote a headline. The largest locomotive builder in the history of the world simply stopped, the way a boiler stops when the fire underneath it finally goes cold. Samuel Vauquelin never saw any of this. He died in 1940, 16 years before the Pennsylvania Railroad's order arrived, still chairman of the board, still, as far as the record shows, a believer in steam. He built the fortress. He voiced the conviction that doomed it, and he was gone long before the bill came due, where the beast was buried. The company did not die all at once. It just kept losing pieces until there was nothing left to lose. After locomotive production ended in 1956, what remained of the business pivoted to heavy construction equipment, trying to survive as something other than what it had spent 125 years becoming. In 1954, in the middle of that unraveling, company management destroyed most of Baldwin's own historical records. Decades of engineering drawings, correspondence, and internal documents, gone, whether out of simple housekeeping or a quiet unwillingness to keep evidence of how the empire had actually fallen. Either way, a company that had once documented every rivet on every locomotive it ever built erased a huge share of its own paper trail on its way out the door. In 1965, the remnants of the company were folded into a meatpacking conglomerate. In 1970, that conglomerate was bought by a bus company. In 1972, the bus company simply closed what was left for good. The empire that had once employed 20,000 people at a single address, that had armed a war and powered a nation's freight, ended its corporate life as a rounding error inside 2 companies that had nothing to do with trains. What was left, by that point, to actually erase? And then, decades later, came the final erasure. In May of 1994, demolition crews arrived at the Eddystone site and began taking the 600-acre fortress apart, building by building. It took 53 weeks, just over a year, to erase a complex that had taken more than 2 decades to build, that had once run around the clock producing over 3,000 locomotives annually. When the crews finished, almost nothing remained standing. Almost nothing. One building survived, the old cross-shaped administration tower, the office block where Baldwin's executives once signed off on locomotive orders bound for 6 continents. It still stands today, just off the interstate, renovated into ordinary office space, a shape in the landscape that means nothing to almost everyone who drives past it. The old riverfront land now holds a helicopter plant run by Boeing, a power station, and a shopping center. The furnaces, the erecting shop, the boiler bays where men once caught glowing rivets out of the air with their bare hands, all of it paved over, without ceremony, the way 70,000 locomotives worth of history dies away when nobody thinks to protect it. One locomotive escaped that fate, in its own strange way. In 1926, this company built a record-setting engine, its 60,000th, a machine so advanced it toured the country as a demonstration piece and set horsepower records nobody expected. It never sold a single duplicate. Railroads admired it and bought nothing. Eventually, it was donated to a Philadelphia museum, moved through the streets on special dollies, and rolled through an opening left unfinished in the museum wall, specifically so the engine could fit inside. Once it was in position, workers sealed the wall behind it. That locomotive has not moved since. It cannot. There is no door built large enough to ever let it out again. That is, in the end, a fitting last image for the entire company. A machine so capable, so advanced, so far beyond what the market actually needed, that it ended up permanently entombed, admired, preserved, and utterly incapable of moving forward. Other pieces of the empire survive, scattered across the country, in better shape, but no less frozen in time. Roughly 1,800 steam locomotives from this era still exist in North America, and a large share of them carry this company's builder's plate, sitting static in town parks, restored and running on a handful of tourist lines, or, in one unlikely case, still hauling passengers in circles around a theme park in Florida every single day. 4 of the small steam engines that carry visitors through the Magic Kingdom were built by this same company, quietly still doing the one job they were designed for, decades after the business that built them stopped existing. The man who started it all did not fare much better than his company, in terms of memory. A bronze statue of Matthias Baldwin has stood outside Philadelphia's City Hall since the early 20th century, compass in one hand and a locomotive design in the other. In 2020, it was spray-painted during a wave of public unrest, the crowd that defaced it apparently unaware that the man depicted had spent his own fortune funding a school for black children and openly opposed slavery decades before the Civil War made that a mainstream position. The statue was cleaned within days. Almost nobody who walked past it, before or after, could have told you what company the man on the pedestal had actually built, or that it once employed more people than most American cities held residents. What replaced this empire was not one company but an entire new industry: diesel-electric power, standardized, mass-produced, serviceable in a day instead of a week, built by rivals who had simply been willing to stop believing their own legend long enough to change. Diesel did not outbuild this company on raw engineering. It out-adapted it, and adaptation was the one thing 125 years of mastering fire had never taught anyone inside that fortress to value. 70,000 locomotives, machines that hauled a nation's coal, carried its soldiers, fed its factories, and set records that stood for decades. A company that taught itself, from a jeweler's workbench forward, how to bend iron and fire into exactly the shape America needed. And then, having mastered that one shape so completely, could not imagine the world ever needing a different one. They don't build them like that anymore. Not the machines. Not the men who fed the furnace and caught the hot rivets and stood under tons of swinging steel every single morning for a paycheck. And not, in the end, the kind of company that could stare directly at its own replacement, on the record, in front of an audience, and still refuse to believe it was already standing in the room.